Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick,
Hey, I'm John.
and this week we don't have Ed with us. Um, and he spent time with family. We had a pretty fun
Did the
event this
goals.
weekend.
Yeah.
Yeah, we did a barbecue competition this weekend, so we kind of had fun with that. But this week we gotta continue moving on. We can't really, sit back on our laurels. This week we kind of want to continue down the kind of, I guess you could say, the filament side of the house, um,
Yeah.
or the material side of the house, I guess we'll call it.
There we go. Yeah, that's better. That's more
Um,
on it.
and of how we do recycle that and how we kind of use that type of stuff. But this week we want to get into resins and also the resin printers. We may touch on a few other things, other ways of doing things with polymers, or resins. Like you start getting into like the SLS printers and instead of some other stuff.
Yep.
But
Yep.
I guess we can get on. Really get you kind of moving behind this. Champ, you've used these things more than I have, so you're
Yeah.
more familiar with the resin side of the house.
It's
What do you think?
Amazon Day, so it's not too late for you.
True.
So, no, but yeah, no. So I've been printing with the resin printer for a little bit now. Definitely wasn't the easiest thing to start with. It's you have to learn a whole new like process, a whole new containment, whole new um, finishing process. Everything about it was new. The only things that were the same is that it's on a linear rail, right? So that's the only thing that really, and it takes G code. So I had to get a new slicer. A lot of stuff kind of came with it, but when we boil it down to kind of the basics of it, it's about what type of print you're trying to do. So we talked about filaments in the last one, and we even went into some industrials, right? But those are still kind of the same, similar process. When we get into resins, it's really like a whole, like you're at this point chemically, you're thinking of instead of heating something to reform it, you're thinking of doing a chemical reaction to solidify your print, and then that's where the level kind of changes and the angle changes so much. But resin's consumable, just like your filaments that come on spools. They're
Mm.
weighted the same, right? So you get into a lot of similarities, but it's about the chemical compound. It's going to be liquid, of course.
Do you
I
see it
mean,
going the same, say, same length?
I would say it's more precise. So I want to break it down into two. So SLA is where it started, and that was like, hey, I could shoot this light at this wavelength. These, I think most of them are 405 nanometers, this wavelength, and it'll solidify this resin here. You're like, okay, well, I guess similar to like if you're drawing or painting, you just hit one point where your brush is, and you're consistently building that, whatever sculpture or painting or whatever. You're adding to it point by point instead of layer by layer like we're used to with FDM. So there's SLA, that's single point, or I think it's like single laser something. I'm not sure what the A stands for. And then there's DLP, which is digital laser. I believe this was the word that I'd like to say. It was like polymerization or something like that. But it's ideally it's instead of a single point on your image and kind of doing waiting for that laser to reach that entire level before it moves the bed again. It's doing the entire layer at the same time, effectively, cutting your print time into like, oh man, it's like a fifth or a sixth of the time. It's incredible, but it's still the same resin, right? So it's still the same stuff, but you're just doing it a different way. So I mean, I think that resins uh, when we're talking about now, we're talking about a chemical reaction. The differences that we should kind of focus more on is like in the chemical makeup, what's mixed
Hmm.
into this resin, right? The resin, so now we think of as compounds, right? Because we can't really do that with our other filaments, can we?
True. Yeah,
You
I agree
can't
with you.
you can't compound things like, I mean, you can, right? But it involves a process of I guess mixing flakes of carbon fiber into PETG or something like
Yeah,
that,
like the
right?
plus stuff and
Yeah.
everything else.
So you can mix those things in there and then extrude it out of pretty much a bigger hot end than your printer, and spool it up that way. Or you could have it, this is kind of a different way of thinking about it, where you're mixing these two liquids, or maybe a solid into the liquid. Maybe you want to put some fibers in to your printer,
Hmm.
or your resin. Honestly, I haven't done it. I think I watched a few videos where a couple people have kind of tested it. At this point, you're a scientist, right?
Right.
Like I
And
feel like you would like it too, because you're just trying to stick. You're just tossing stuff stick, so it stick, right?
yeah, pretty much. And
Whatever
some
works.
people, I've seen the same videos and people try to throw in, hey, I can use this type of plastic and go from
Hmm.
there, or this type of bedding material and, help with the strength issues.
Right.
Yeah, did it work? Probably not. But it's a good attempt. I'll say that. The one thing that people need to think about when you're kind of working through the resin side of the house is now you're really getting into a chemical. You're no longer dealing with something that may give off VOCs. This thing is going to
Oh
give
yeah.
off VOCs.
Oh yeah.
Um, so always check the chemical makeup of what you're using. Um, the last thing we need somebody to do is chlorine gas themselves.
Exactly.
Um,
Oh man.
so, please be careful if you're going to attempt resin printing. We'll say this now before we get too deep into the weeds on this thing, is, be safe. Read the chemical makeups of it. Understand that you do need some sort of ventilation
Hmm.
and you
Hmm.
do need a way of containment, as
Yep.
far as containing this stuff. Don't let kids anywhere near it. Don't let your cat knock it over and, roll in it, or whatnot.
No. Most
Reason I
people
bring
are
up cats
very
is, well, they're kind of
allergic.
into things. Yes,
Yeah,
exactly.
cats will get into it because it's moving and lighting up and flashing. If they like lasers, they're gonna go to it. But absolutely. I mean, I think I think it varies on the level of your allergic reaction, much like um, people's allergic to shellfish. But if you don't know, I mean, why would you test it, right? Don't stick your hand in there. Don't put your finger in there. If you touch it, you need to go clean your hands. Like it's like washing it in the sink. Alcohol gets it off pretty well actually. So
Well, that's
just
always a
keep those
bonus.
things around. Yeah, it's nice because same thing. I mean, the whole idea of the alcohol breaks down the materials on your print bed when you're wiping a print bed off for FDM. Makes sense. It's if you spray it on the resin, it's already a liquid, so it's just gonna make sure that liquid doesn't stick to anything.
Right.
So
And now we also have the ability to get the water cured resins instead of
yeah,
the ones that have to be cured in alcohol. So for the ones who are, have a sensitivity to rubbing alcohol or anything of that nature, you can always attempt to go over to the water soluble
yeah,
stuff. You're still going to throw it through the same curing process and stuff like that. However, instead of using a 99% isopropyl alcohol, you're going to use tap water.
yeah. It's
Um,
very potent smell. I tell you what.
but but the thing is like the water ones, you can wipe that stuff off and it'll go right down the drain. It won't hurt anything.
Yeah,
They're septic safe. They're also, well, I'm not saying dump an entire bottle down there. Um, they're also,
right.
not they're environmentally conscious, I guess you could say. It also saves you from having to buy a whole, you know, gallon and a half isopropyl alcohol.
Yeah, yeah. And I mean, depends on who you are. I mean, some people, if the isopropyl gets too dirty, they kind of dispose of it and get more. I mean, honestly, you could clean out, you can recycle. Like, oh, that's a good point. So we talk about sustainability with all the other filaments, didn't we?
Yep.
You can actually recycle your isopropyl alcohol. I know we're talking about resin as the consumable of this episode, right? But
It's one
this
and
is
the same
part
at
of the
this point.
process, right? Yeah, you need this to be able to do that. So you need alcohol, isopropyl alcohol, to be able, for the most part, not everything, like you were saying, but at this point, a lot of them are needing that to cure or wash. I mean, I should say that you can get all that excess resin off of your print, but you can actually use like a black light or a UV flashlight and kind of decant it and get it cleaned out. You're not going to get everything back. You're only going to get a portion of it back, but you'll get some of that isopropyl. Um, so it's just something to think about because as you use these things, it's going to like you're going to change colors of resin, right? You're gonna have different types or brands, and they tend to get mixed together in that cure tank, so or that wash tank, so
Yeah.
it starts to discolor, and that's something that people worry about.
And you start dealing with that when you start dealing with like the ABS like resins. You start
Oh
dealing
yeah,
with the super clear like glass resins. What is it, artist resins now too, where they're
yeah. It's
clear and shapeable.
it's about the I think the curing or how it the UV light hits it and how it we talked about it in the previous couple podcasts where we had that pyramid of like semi crystalline and
Mhm.
amorphous like these still do have lattice structures, right? So you still will see that more semi crystalline structure, but um, there's definitely people out there that are trying to kind of use the idea of a chemical process to get maybe a rubbery, just like you were saying, TPU or something like that,
Mhm.
similar like resin, um, and they're getting successful prints out of it. So, I mean, it depends on I guess the tools available to you if you can synthesize, you know what I'm saying, a resin.
Yeah.
Most of the time, people are probably going to buy some of those, but I would say those are still kind of on the more advanced side. So if you're just starting out, I wouldn't go right into that too quick.
Yeah, definitely
But
not.
it does sound cool.
It's like the impact resin we saw at Rapid. Um,
Yeah.
from Fosen, and I think Fosen partnered with another company to develop it. Um, and it's awesome. I mean, you're driving nails with a resin hammer.
Yeah. Yeah, they could have put a little bit more infill, give it a little bit more weight behind the hammer, but it worked. I think they called it Onyx or something similar like
Something like
that,
that, yeah.
Impact. And they've got something that looks ceramic-ish. So they've got there's a lot of things, but at the end of the day, these are all chemical compounds. So you got to make sure you're looking at, they're not gonna be all made the same if they're from different developers or different, sorry, if they're from different manufacturers. They're gonna be completely different. Now, I think we've gotten past the point of the basics though. I think if you're printing, like if you get a resin printer, be safe. Get with the I guess the water soluble,
That would be your
or
best
the
bet, yeah.
yeah. I mean the same brand as your printer is a good place to start, and then just get comfortable with that because I think it's gonna take a while for the to get a comfortable with the slicer because the slicing process was a little strange. I'll say that much.
And there's a lot of people who have done, some videos on YouTube and stuff like that that showed people
Yeah,
how to really use those slicers and stuff like that.
yeah,
And, we may have to do one of those just to be able to help people out, kind of give people best practices.
yeah.
But
Some of your normal ones, like I think Prusa's slicer has, and their for their SLS printer, they have it included in their slicer.
Super
So
Slicer does too.
yeah, so Super Slicer does have quite a bit more functionality, but I think the base one, I don't know if they can let you do a custom one and add Elgo or Anycubic, but usually those are I mean, I would say those are like the Ender or the Prusa of, the resin printing world,
Yeah,
the
I
basic
know
ones.
for like Prusa Slicer and for I think for Super Slicer and I think Orca Slicer, maybe only the um Prusa SLS printers. or
Yeah,
sorry, SLA printers.
yeah, it makes sense if it was
SLA,
SLA.
SLS, two different bags animals.
Two different rabbit holes.
Yep.
uh, I mean, we probably could spend a whole episode on metal prints and stuff like that, um,
The
but
weird
yeah,
and
I mean,
wacky.
I think this is where a lot of that started, though. I would
I
say
think
at
so
least.
too. Because if you think about it, if you have a resin that is a metal like impacted resin and you print that out and it kind of forms your layers and forms your layers and forms your layers, you throw that through a curing tank, you can melt the resin out,
Hmm.
leaving a metal shape of some sort. It's like the guys who use the metal impregnated filament and all they do is sinter it and then guess what? They have a metal print.
Yeah, yeah,
Kind of the same process. It's just the thing is once you go from the resin printing, like I said, you start getting the weird and the wonderful, or just the flat out strange, um, printing methods and stuff like that. You start getting that SLS and binder jetting and SLMs and stuff like that.
it gets it becomes a focus on what is like not just what is the point of your print, because I mean at the end of the day we're printing stuff, a lot of us, just because we can.
Yeah.
So there's no point. It's just I can, so I will. But what made me take the step into resin, which then started like this whole kind of mountain downhill um, kind of rabbit hole that we got going, was the detail. 8K, 4K
Hmm.
resolution? Are you kidding me? You have a 4K TV in your house, right? Now, if you just took a corner of that and you said whatever's on that screen, if I could 3D somehow 3D model it, scan it, if you're using a scanner, but get that 3D model somehow, you can make that thing come to life with crazy amounts of detail. And I think the biggest thing is the overhang issues, and you have the supports and the curing. It makes it so much easier on a resin printer versus the supports that and the possible artifacting you would experience and the loss of detail on a FDM print or FFF print.
Yeah, and now you have the 8K resins that support that type of stuff.
Yeah, I was curious on that because I was thinking about it. I was like, what? Like we were just talking about like what makes these different, right? Um, and I think I got my answer. I'm still kind of, I guess, on the fence about it, but it just kind of makes more sense to me. Is
Hmm.
like we talk about layer height with FDM, right? We talk about a point 0.2 millimeter layer height, right?
Yeah.
For this, we also have a layer thickness. So what does that layer cure? How far from the bed is or how far from the LED screen is your bed that's getting cured? And for the most part, most of them start with minimum or default layer thickness of 0.05 millimeter. So much more fine than your FDM. So even if I just look at those two things, I can guarantee you I'm gonna have more detail.
And I really wonder if, like, we have 4K resins. We
Yeah,
have 8K resins based on the resolution of the screens, the LCD screens and stuff like that that are in the
yeah.
printers themselves. But if you think about it, I really wonder, and this is just me wondering out here in the blue someplace, is there a viscosity issue? Is there a viscosity difference between the 4K resin and the non 4K and the 8K resin? Because if you think about it, something that's a little bit more viscous.
Dude, there's gotta be.
It's you got to think about thinner liquid is going to give you just that much more detail because it can kind of fit inside crevices and things like that. So I
Yeah,
really
no, that
wonder if it
makes
is a
sense.
viscous issue.
You're making too much sense, Nick. That makes a
Oh
lot of sense.
shit.
I mean,
Well, I'm gonna go
listen,
back to the drawing board then.
you're making too much. No, see that, but that's the thing is, so earlier we started with your basic. You just get whatever your brand is. That's probably a safe place to start. I'm not saying get 20 bottles of whatever your brand is and say you're
Yeah.
good,
And
but
there's an
get one
ass of
bottle.
brands too, by the way.
There's so many, but not all are made the same. I'll tell you that much right now. But like, so I want to kind of go through this path with it. So your basic one, you've got most of the time people are going to do with clear, white, or gray. Those are kind of your standard ones, just because a lot of the times these were used for models that were getting painted, and those were very easily primed layer colors, or primed colors for a model, right? And it's easy to paint. Um, but when you think about it, if you get a clear, right? can't I just add dye to it? Or a
Yeah.
white, can't I just add dye to it to make it whatever color I want it to be? And that turns out that's absolutely right. So I say basic, maybe get a couple dye, some dyes and kind of toss it in. After you get a couple prints, of course, get comfortable first before you just go for for something too like don't put too many variables in. I should say too many points of failure in, but
And it
you
should be
get
the
to where
powder
you can.
dye too.
Yeah, you can get to where it's just additives. So you were talking about viscosity, and that's what got me thinking. So the viscosity is definitely something that needs to be taken into account because um, when we were talking earlier about adding things to the resin, this is the same thing if you're changing the color, you're adding a dye. Same thing as if you're saying, hey, I want to reinforce it. Think about concrete with reinforced with um, rebar, right? You're adding stuff in there. So if you have like little fibers and you add fibers in there, would my print not just be stronger at those layers?
True.
Um, so it's something to think about, but like again, it's another point of failure because you could be just creating an air pocket, and you know what happens with air pockets. Um,
Yep. Things
those
tend to
tend to become
explode.
breaks. Yeah, those are broken. So like that's why I kind of say err on the side of caution. But I would say intermediate resin printing is maybe adding something to your resin while you're printing, right? Because at that point you should be comfortable enough slicing and printing. Um, I think one of the ones that I really liked the color of was I think his Thomas Sandlander did
Oh, the
graphite.
yeah, the graphene, yeah.
He used a lot, so it made it like very chalky in the
Hmm.
print, so it kind of it lost its structure, right? So it wasn't as nice, but if it looked cool. I mean, for what it's worth, it's an experiment. You're trying to make something, right? So the
Yep.
fact that you can change the overall finish by adding a chemical or an ingredient at the beginning, I'd say you're at intermediate resin printing.
Add a metallic powder to it, make it magnetic.
There you go. See, and that make it conductive.
Yep.
Boom. You have something that can be a conductor. You can have there's so many different applications at that point. And then when you can get, I think you need more industrial type um, manufacturing, I guess,
Hmm.
tools and thing machines like that. If you want to make kind of like how Fosen has the Onyx, or Polyspectra has what did they call it? The core or
Yeah, the
something like
core
that.
line. Yeah, core
Yeah.
black and stuff like that.
Um,
It's darn
th-
near indestructible.
yeah. So these are the resins that you see. You make a print. Like I think we saw it at Rapid, where they had it in. Like I'm thinking about printing, and when you think FDM, what's the chemical process that's happening that makes it work or makes it like extrude?
Yeah, it's a
It's
solid to a
it's just
liquid back to a solid again.
right. It's temperature that it's got to put there, right? So I'm thinking about okay, means that now we're on a different plane. Like curing doesn't matter how hot it is. I mean, it probably has some type of heat combined with, of course, the wavelength, right? I'm not saying there's absence of heat, but it's different. So when we saw their boiling their prints after they're finished, I was so confused. I was like, how is that not a goo right
Oh,
now?
that's the core green stuff. Yeah.
And I was like, how is that not goo? How did you not just like make that into and it's because they're affecting the chemicals like the polymer connections, the structure of the material. It's incredible that at that point I think that these are the I would say advanced prints.
Oh yeah.
Um,
And the thing is, you guys start thinking about it that, we need to make sure everybody also understands this. I know we understood it, to be honest with you,
mhm.
is you start getting into different levels of equipment when you start dealing in resin printers, even leading up to that intermediate section.
Yeah.
We're not going full bore here. We will, believe me. Because you
You gotta be
start
careful.
dealing with your smaller anycubics and you start getting up to your anycubic AKs. Then you start
Yeah.
getting to the Fosens, which are just ginorma. They're huge,
Hmm.
huge printers. Um, then you start getting into, Formlabs,
Yeah.
uh,
Yep. Yep.
which is a different breed of printer. They do have the smaller printers. They also have the big printers, which run off of cartridge.
Hmm.
And they have I could tell you they probably have one of the most ingenious pieces of equipment out there is that auto print system that they came out with. Remember that?
Well, I remember them talking about the spaghetti detector thing
Well,
that you kind of roped in, but
for Form Labs, what they have is they have the ability to like change the print bed for resin printers.
oh, really?
Yeah,
I didn't. No, okay. I guess I didn't know that. No, because I remember. I mean, I definitely remember the cartridge system and kind of. I think Adam Savage got has one or two
yep,
that
he
he
does.
was kind of experimenting with. But um, yeah. I mean, for me, it's the sheer size of it that's enough. I just am like, oh yeah, make it
Yeah,
bigger.
it's
So
called the Form Auto.
form auto. Okay,
So it's a
that's
form
pretty
auto.
cool.
It changes the beds out of your
Oh, it's a
SLS
bed.
printer.
It's a bed swap. That's
Yeah.
crazy.
It's a little expensive. We got
Yeah.
to see it in motion at Rapid, and
Oh, look at this
it's
video.
definitely awesome. I'm gonna tell you that. We got to see it sitting there next to us. I was very intrigued with it because technically you could set up an entire print farm just using the Forum Autos and the Forum Lab printers. Um,
Oh, that's right. We were talking about that. I think that was the same day we looked at that modular, I think Visitech, that modular curing setup there where
yep.
they had it. You could get a whole bunch of Anycubics and have a modular curing
There's
grid.
also the day we looked at the SLS printers
Oh man,
from Forum Labs because they were sitting right next to us.
that's so incredible. Go to Rapid next year, guys.
Yeah,
Um,
we'll be there.
incredible. It's
Well,
just what they're doing. It's just wild.
but I'm gonna say that's probably one of the more intuitive things I've seen, especially when it comes down to SLS printing because not SLS, but freaking yeah, well, close enough.
Eventually.
Yeah, SLA printing. But the thing is, if you think about it, it's easier for somebody to create a print farm printing high quality resin prints.
Yeah.
However, you gotta, pay the piper. They're not cheap. They're about $4,000 just for the Form Auto, and then not including the Presto printer, which is about 2K.
Well, the nice thing
Um,
is that they have the enclosure, like their enclosure is robust enough. They've got fans built in and things like that. But
yeah,
I would say still want to be careful about keeping it in the same room as you too. But I think that their systems are just much better,
yeah.
as far as
Their
keeping the
materials
user
are
safe.
are absolutely, crazy because they have some cool materials. They do a lot of the dental implant materials. That's one thing they're known for. They have a dental line that they do, which kind of makes it pretty interesting. And then, if I'm not mistaken, they were the ones who first came out with the SLA printed cranial implant for the eye socket. I think is what they came out with, good with their flexible filament that I
Was
think they
that Form
designed.
Labs?
Yeah, Forum Labs.
I think they're also. Oh, I might be mixing them up with one of the others that were in that same area. But wasn't there a flame resistant?
They are. Yep.
They
There's.
had like
I don't
a
think it's Forum Labs, but I know it's somebody.
somebody was there. I think it was Form Labs
It
though,
might
but
be them.
or no. Well, we don't have to sit on it too long. I'm pretty sure that was a filament though, not a resin.
I
So
wouldn't be surprised if it was a resin too. To be honest with
yeah, I would not be surprised. I mean, especially like Fozen is the one we keep coming back to, but they're definitely the ones where we saw so much of the tooling that you could print. I mean, in action, right?
you. Yeah.
I think I would have liked more weight behind it, but that's what happens when you don't print it fully 100%.
Right. And there's a lot of stuff that people see out there that people kind of get behind. And if you're in the greater area, if you're in the greater LA area, I guess you could say Anaheim, California next year, about April time frame, definitely, go up there, take a look at Rapid. Um, I can't remember the exact dates for Rapid 2024, I believe it's the first week of April, if I'm not mistaken.
Well, I think so. I think last time it was May, but this time it's
Yeah,
gonna be earlier.
I think it might be
No, it's
last week.
actually it's last week of April. It's
Last week
20,
of April.
well, 23rd, 25th.
All right. Yeah, we'll definitely be out there.
Yep.
You have to go out there and look for us. So we'll be walking around, um, gawking over something or talking to somebody or, figuring out a way to get more people on the podcast for you that you guys can actually talk to.
Yeah, I'm gonna be staring at a lot of stuff. It's a pretty cool experience all overall.
Yeah.
Check it out. We got some other stuff that we're kind of covered on there. It's where we saw Ulindo and some of those
Yep.
other companies that kind of spoke to us. So shout out to a
And,
lot of those guys giving us
you
some
know,
time.
exactly. If you think about it, also your SLS printers, I don't keep saying SLS, I have SLS on the brain.
You got to get
Um,
one now.
sh-
Just kidding.
yeah, go broke in the process. You're talking, 50 to
S-
$60 a kilo.
Sell the car.
Yeah, I got one to sell if anybody wants it.
You can print a car. Come on.
Yeah, there's that guy
Eventually.
printing a Ferrari with an ender, okay? Or a Lamborghini with
Just
an ender.
one part at a time.
Yep. But you have the guys doing the what is the post processing for the SLA printers that are doing the
Yeah.
hey color changing and stuff like that. You also have guys doing stuff where it's flexible film. It's kind of like a modified TPU. Um, if you're in the dental industry, healthcare, the SLA printers or DLP printers, it might be DLP that they would use, would be your best bet.
Yeah, I think
For
it's DLP. It's more. It's just so
your
much quicker.
dental present if you're doing your dental resins and stuff like that for making in-house dentures and whatnot.
Hmm.
So before going to something a little bit more extreme.
Yeah, I think there was. I mean, it's dimensional accuracy is very important to look at. There was some filaments. I think Nano Dimension was the company we saw that was
Hmm.
making some. They had some gears that you could actually put an Allen wrench in and spin, and see. It was like a very like your smallest Allen wrench, like or Allen key. It's definitely small enough to fit that. So it was pretty cool to see all these advanced ones and the usability. I mean, they have to make it to where it's so precise, right? That it's incredible, and not
Nano
everything can
Dimension
do
had
that.
stuff under microscope.
Yeah, you had to get a microscope to see the detail. That's your eye couldn't see it just by staring at it. I mean, I guess you could, but it's hard to see the detail. It's hard to enjoy the detail, right?
Right. And that kind of shows the benefit of your SLA and DLP printers is and also the resins that go along with it is the fact that some of your prints are a little more enjoyable. If you want to print your costumes, or costume parts, you can print a lot of stuff from SLA and DLP printers. If you want to print spaceships and stuff like that, you can print with SLA and DLP if it's nothing too absolutely, crazy.
I think impact resistance and temperature resistance are key facts to look. I mean, if we had to break it all down into like why first off why should I resin print? Detail, your detail, right, is huge as far as how much you get from it and the speed that it prints at. And then why should I add or get these advanced filaments? It's impact resistance, it's temperature resistance. Like these things have to be kind of considered if you want to put a part outside. You want to put a part in your car. You know how hot your car gets sitting in a parking lot if you're at work all
Hmm.
day, right? So like these are things that have to be considered. I mean, it also kind of goes on to that piece where we'll have to eventually touch on in the sustainability thing is like if they're that much more resistant, that means they're that much more resistant to breaking down. If you throw it away, right?
Right.
So it's a double-edged sword. I mean, you got to figure out how to take and do something with the unused supports or the unused filament, and and
Hmm.
I I think the answer is simple, man. If you get more filament, you get your supports, you can kind of crush it up. We talked about like recycling, um,
Add
FDM
enough
or
heat to it.
filaments. Yeah, and then you can put it back in with the resin and it cures again and it'll be mixed in together if you get it fine enough. Like it's something that you can consider. I wouldn't say just go for it, but like I would say sustainability wise, keep it, use it for something else. You can use it as a mixture to make, a resin stronger, or you can use it as kind of a compound ingredient if you'd like. But you need to figure out how something to do with it.
Right. And the thing is like you start talking about when you start to recycle, the resin prints and stuff like that, especially failed resin prints.
Hmm.
Um, you can start really dealing with some interesting things because I'm looking at Form Labs and stuff right now also. Um, Form Labs makes, and I hate to keep going back to Form Labs, but I think they're kind of like the leader in some of the filament world right now. And one of those filaments they're doing is silicone. They're also doing a polyurethane. They're also doing
A resin?
ceramics. Yes.
That's crazy. See, ceramic was the one I keep seeing pop up, and that's what I was like, ceramics. I'm sure it's ceramic like, but I can't be certain that it's the same. I bet it's a similar process and probably the same chemical makeup.
Yeah. And the thing is when you start talking about um the like silicone, it is a good it's expensive. I'm gonna tell you that right now.
Ha! Would
Uh
not doubt it.
$349 with tax. But they're making shock boots for shocks out of it. And flexible things. That's coming out of a resin printer that's usually set up for a regular 3D printer. But the thing is, with that, means you can kind of recycle it the same way as you would any other type of silicone material.
Hmm.
Um,
Right. I
oh,
think
Batman. Listen to this. Just to give you an idea what we're dealing with here, when start talking about this stuff. As far as this one, they're post cured for 30 minutes at 60 degrees Celsius. Your shore hardness is 40A. Ultimate tensile strength is 5.5 MPa. Elongation at break is 230%.
oh wow. See, that's the thing that's the thing that we did. Didn't we did a test like with Polyspectra
Hmm.
and the core. I think it was just one of the core ones where we held a weight to it to see what weight would it break at, and it was incredible. Like yeah, I think it was like I don't know what the unit of measurement was to be honest
I
with
think
you.
it's Newton meters.
Newton meters. So I think it was getting up to 200, 300 Newton meters before it broke, which is, I'm going to be honest with you, if you ever felt like 50 Newton meters, you're going to feel that in your shoulder if you're not ready.
Right.
You
And
know?
like this is tearing at 12 kilonewtons.
Oh,
W-
man.
With a and so here's where we start getting on the physics side of the house. We start
Man,
talking about filaments. You start talking about glass transition phases. Especially when you talk about on the filament side of the house.
that sounds familiar.
Yeah, a little bit. Um, Negative 110 degrees Celsius.
Wow. Wow. That's just crazy, man. Like there's so much that goes into um, the materials and the testing of this, how you could figure out that this is it works. It must have taken so many attempts, but that's the beauty of 3D printing, isn't it? The rapid prototyping is so like ready and available.
Either that or the rabbit hole that you had to follow to figure it out at the end of it.
Yeah, or you just take shifts and it's when you sleep you're not so when you sleep someone else is doing it.
Right.
So,
And the thing is they got more and more and more different um, filaments out there, stuff like that that people could play with and stuff like that. It's and some of them are just as expensive as others. You start getting into the rigid filaments that it looks like it actually run on yours. They sell it by the bottle now, um,
don't
which
tell me this.
is your polyurethane. Yeah, you're not going to pay for that. It's $149.
Don't tell me this. Well, if I can get a gift card, cough cough. No.
He's looking for
Uh,
his Christmas gift.
yeah, right. It's
Um,
Christmas is coming up. No. Oh man.
but man, it looks pretty cool. I mean, you start looking at some of that stuff and you start to geek out about it. Me, I'm a science and history guy. I can tell you I don't like math. I don't like, any of the other stuff. But Science, engineering, and history and stuff like that is, it's kind of like my background, along with, a little bit of law enforcement, the criminal justice side of the house, when it comes out of school. But
Right.
it's just, when I start seeing stuff like, I start seeing chemical makeups like that, I start kind of geeking out a little bit, 'cause it's like this should not work.
Yeah, it's strange. I mean, honestly, it's all about it. Like, of course, we talk about experimentation, but like, yeah, you start learning more and more about the world. You start learning more and more about kind of some of how things react, and when you start putting those pieces together, it's crazy what is possible with like some of the tools that are like readily available to you. Like. I mean, if you wanted to and you had the space in a KUKA robot, you can make yourself a spaceship.
Yeah,
Like,
right.
come on.
And the thing is the resin printer is great for people who are getting into a secondary hobby. Especially if you're trying to make jewelry. Resin printers are great. You can make your ring
Yeah,
your ring
rings.
molds and stuff
Yeah.
like that. And then do lost casting and stuff like that. That's all possible, with a resin printer. A little easier than using an FDM printer or an FFF printer. Um,
Yeah.
so, it's always something to think about. And if you think about it, that also, um, what is it? The 3D printed shoes are actually resin printed.
Oh, the Adidas.
Adidas, yes.
Well, see, okay,
Or are
here's
those SLS printed? I think they
no,
might be
no,
SLS printed.
they, I think they have their own
Uh,
they have a two-phase print like curing style. It's so this is where we get into kind of a gray area. So they're not only using UV curing resin, they're using resin that cures at a temperature as well. So they have to get their temperature up to a certain point while they put the it's just the soles, it's not the whole shoe. So they put the soles in to a centrifuge, and they'll, instead of curing it like or washing it like you're putting it in water, they'll spin it and also heat it at the same time. So you're hitting it with light, a certain wavelength, and you're heating it like you're doing two different chemical processes at once that both in its own way hardens your um and solidifies your print. So like that's how they were able to put it through the 9,000 step test or whatever, right?
mm-hmm.
So it's something. So if you haven't looked at it, it's the Adidas 40 forward. Um, it's crazy. For the letter D and then FWD. I'm pretty sure, but I mean they're pretty pricey, but they're supposed to be engineered to deflect your downward weight of a step forward. So they want you to keep walking. I mean, that's the point of it. Why not? It's gonna cost you a pretty penny though.
Yeah.
So, I mean,
Huh.
I'm curious. If I like win like 200 bucks here or there, maybe I get one just to tell you about it. I'm just curious about it, you know.
That's interesting. I just ran across a something from it's from Ultra Print.
What's that?
It's a resin. I'm trying to find more about it. It's a 12K resin.
Is there even 12K printers around? See,
Yeah,
that's
they got
where
one
I.
from Anycubic.
Oh my gosh, Anycubic, of course it's Anycubic. Can we even tell at a certain point past, like, can you tell past, like, we talked about this with, we've had this conversation, I know probably a few times before. It's like, oh, they got 8K TVs. Listen, sir, can you tell between the 4K and an 8K?
Yeah,
Because to me, I can mathematically, or like if I put it in the size of dimension, yeah, I get it. There's more pixels, there's more detail, but like, come on.
yeah. It's the Photon Mono M5S. Boasts 12K resolution at 19 micron X accuracy.
Ridiculous.
But like you said, can you tell the difference?
Ridiculous. Well, I mean, I'm gonna be honest with you. Um, if I had to choose which side I'm on, I would like to pick the higher resolution, and that's just because, I mean, it's the same reason why I want a graphics card for my computer that's the highest one, or anything like that. It's like if it's there, I would like to see the capability of the top-notch,
Yeah,
whatever.
want to push it.
Um, yeah, push the boundaries a little bit. Maybe you learn a little bit about it. Maybe you see something like, oh, um, this like we were talking about adding materials to your resin. Like maybe this maybe zinc is shavings is what I need to add to this print, and then it becomes like the most durable or the most heat resistant or whatever. But you look for properties that exude the chemical characteristics that you want in your print, and that's kind of what you go for, you know. And that, I mean, to me, that part right there makes it so custom, so like advanced in that sense that like that's why I would like to do resin printing. However, it's a very, very hands-on,
Right.
long process, but
And
worth it.
yeah, and the thing is, we got, our group of individuals that we hang out with, and I guarantee you somebody is going to pull the trigger on a 12K,
Oh
um,
yeah,
mono
just to say they
freaking
did.
something. Exactly, just to say they did it, but also just to say, hey, look, I printed a squirrel, and it's okay.
It's gonna be something like a it's gonna like I mean we what happened I was about to print the biggest benchy you'd ever seen, but I decided to print a dragon instead. So like you see what I'm saying? Like it would have been I printed a 56-hour print. It probably is what kind of ruined my printer's harness, but like we pushed it to the bounds because why not?
Yeah, I printed a 12K Vinci.
Is max bed size. I think also though, to be honest with you, when you get some of those higher 8K, 12K, the print bed is bigger, isn't it? So
Yeah, this
you get
one
it.
is 7.87 by 8.58 by
Oh,
4.84.
that's bigger than my bed. I have the Anycubic Mono X 4K.
Hmm.
It's that's a bigger bed. That's a bigger bed. I mean, to be honest with you, it depends on what your print is. You could probably most of the time break your print up into multiple pieces, but when you start doing that, we said it earlier, you introduce more points of failure, which can kind of ruin your print. So you
Yeah,
gotta be careful about that.
I'm looking at it. It's like what 11? It's like a 11,520 by 5,120 resolution.
Come on, man, you can't see that many pixels. Tell me how many pixels you see right now.
Yeah, one.
It's all the same to me. At a certain point, it all blends together, and you're not gonna be able to tell. Like maybe somebody will be able to tell, but like, how many people wear glasses at the office? You think they can see all them pixels?
Yeah, no.
No, no. I'm not saying don't push the boundaries, but at a certain point I'm asking a question of how far is
Too far.
negligible, I would say. Diminishing returns is what it's like. Okay, you work so much harder to get this into a higher resolution. Does that mean my print's gonna take 6 times as long or twice as long? If not, sure. But what's the advantage and what did I gain from it is my question.
Right. The
That's
thing
all.
is a lot of guys who are buying these higher end printers like these and stuff like that are the guys who are building like Dungeon and Dragon things and stuff like that. Things who people who print their collectibles and their tabletop game stuff. Because they wanted to be the biggest and the baddest on the planet.
I don't buy my pops figurines. I print them.
Right. There's always that one person. You know, I open
Yeah.
sourced my pops. You know,
Like you can't sell those aren't the same. That's copyright infringement.
they're
Not if you
ops
don't
instead
sell.
of pops.
If you don't sell it, it's not copyright infringement,
Yeah, it's ops
right?
instead of pops.
You
It's
got to be
called
careful
oops.
about that. You should Google it and consult a lawyer.
Yeah, don't listen to us.
Please, dear God, I am not a lawyer. This is not legal advice. You
Somebody
have to disclaimer.
2 weeks or somebody they're saying, "Well, I'm making this product called the Oops." It's like what?
I will find you and we will split. I'm okay with the 5%. You know, I'll take equity in your company. We'll
we'll be your
talk this
printing
through.
support.
Yeah, we'll talk this through. But yeah, no, I mean, to be honest with you, there's a lot of stuff that we touched on, but I think at a certain point we're getting into a different chemical process, and we're gonna at that point almost touching a different type of printing. So if we're talking about resin printing, we're talking. I'm saying that probably the most efficient is DLP, which is that entire layer at once. But like if you feel comfortable with the SLA, go for it. Why not, right? Um, they have different advantages, of course, but also it's increases your print time
Right.
to go SLA. So because you have to do every line, it's a lot. But yeah,
Yep.
no, I mean it's up to you really. But I think that we have a lot of these things touched on, and the printers. I mean, if you ask me, they're on a linear rail that goes, it's in one dimension. So like I would say a lot of these SLA or DLP printers are very similar. It's resolution that you're changing, it's the size of the print bed that you're changing, and most importantly the filament or sorry, resin.
Exactly.
So,
But I think that, we've kind of hit the nail on the head a few times, and I think that, I think we got the point across at this point. And we don't want to, bore anybody, to be honest with you. We want people to enjoy the
yeah.
hobby, get into it, have some fun with it. Let us know what y'all print. We're kind of interested. Um,
Yeah.
Maybe a little bit more than usual, but we are interested in what you guys do. Definitely go take a look at your printed heritage. If you see anything on there that you guys, I don't want, let us know, or something you don't see on there, let us know that what you want. We will be starting to do more of the flag prints and stuff like that for y'all. Getting some of them out
Yeah.
there. We got to do some demo flags for you. We may even start doing a little bit of your SLA 3D printing. Sorry, not SLA. Damn it. Yeah, SLA.
SL, SLA or
S
SLS?
SLA
Trying to give me a couple
um
thousand.
lithophane printers.
Oh, you know what? I did buy that white resin
So
just
we
for
might have
this.
to try that just to see how that goes.
Yeah.
And kind of, let y'all know. But, we want to thank you. We are definitely getting closer and closer and closer to that 2,000 all-time download mark. I'm actually checking the stats right now, to see kind of where we're at. If I can get past all of the stuff about what's going on currently in the Middle East. Um,
It's very
so
unfortunate.
yeah, that is. So we're at 19 that we're at 1,955 all-time downloads, guys. And
Wow.
it's fun. We enjoy it. We like having fun with it. We want y'all to learn more and have a little bit more enjoyment out of it. Looking at, where some of these people are listening to us from, it sounds like some probably a fun place to visit, some places to go. We hope to see you at some of the events that we're going to. We will actually be at South Tech in Greenville, South Carolina at the end of the month. So we will be out there. It will be me and Ed. And then, of course, we will be at Rapid next year if we don't end up attending some more of the 3D printing stuff in between. So, I just want to say thank you, and y'all have a good one. I'll turn it over to you.
Yeah, yeah. I also echo Nick says thank you. I mean it's crazy. I thought we were a little further. I thought we were closer to like at around like 1800, but that's a huge number. It's crazy to hear. It's crazy to think that anybody else would be, listening or anything at all. Just kind of the topics we're talking about. Some people could bore them, I understand, but this is very interesting, and being able to synthesize and create anything that's in your mind is to me it's a superpower. So um yeah, just keep in mind some of the stuff that we're kind of doing is of course the printed heritage is something. If you have any ideas, you have any questions or any concerns or comments or anything at all, just let us know. Try it out and see if you or check it out and see if you like anything. Of course, there's the website with the t-shirts that Nick has that's connected as well. So go ahead and check some of those things out. We encourage you to kind of let us know if something's not working as well, and if something's not clear. So we just want to help you guys in that sense. But yeah, stay tuned with some of the things we got going on here, and we look forward to seeing you maybe at Greenfield, maybe at Rapid. Honestly, if you haven't gone to Rapid yet, you need to at least see one.
Oh yeah,
So
I agree with
it's pretty incredible. But yeah, other than that, guys, keep it printing, and yeah, we'll see you in the next one.
you. All right, y'all. Have a good one. Bye.
Take care.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. We'll see you later.